Okay, students, let's begin the class by first discussing the quiz. Okay, so your problem have a of minus 6, 8, minus 2. Yeah, your task is to find out what kind of b so that this problem has solution. Yeah, and the step is given already in the problem that you have to first make it upper triangular matrix. Okay, so what you need to do is that you first augment the matrix as stated in the problem. Yeah, augment the matrix. I even write down you have A and then the B as the additional column. So you write down this is B1, B2, and then B3. Then you remove the second row. Yeah, you make this to be 0 by using the first element in here to be the pivot. Okay, so this is called the pivot because we want to eliminate 2 by using 6. So we write down 3R2 plus R1. Okay, so that we can remove this number from 0. So what we have is the first row remain the same, but the second row here becomes 0, and then 3 times 2, 6 plus 8, 14. We have 3 times minus 4, minus 12, and then minus 2, so we have minus 14. And this is just 3b2 plus b1. Okay. Any questions so far? Okay. And then what do we do to eliminate this?
Bagi dua yang
Yeah, we have to multiply this by 2 and then plus the row number 2. So in this situation, the pivot is 14. Yeah. So in this case, I will note down the pivot. Yeah. The pivot becomes 14. So that's the pivot. In this case, minus 6 is the pivot. So we do by 2 times R3 just plus R2. Okay. Then we can eliminate the third row. And this becomes minus 6, 8, minus 2. Row 2 remain the same. And this become all 0 except the last element in here. Yeah, this is 3 times no, not 2.
Oke, ingat ya, gue udah seperlan kan.
2 times b3 and then plus b2. Okay, so in this case, if we want this to have a solution,
Ada satu juga nggak sih?
wait.
Satu ini. Ini juga harus ada satu sih.
No, plus this. Yeah, so this is 3b2 plus b1. Sorry.
Kali 2.
No, 2 times the third row plus the second row. Yeah.
Aku salah sih.
So we have 2 times b3 plus the second row. Okay. So what do we want? We want for this to have a solution, then 0 times x3 must be 0. Okay. So that means this part must be 0. Okay. The condition 2b3 plus 3b2 plus b1 must be 0. Okay. So in this case, b3 minus b minus 3 over 2 b2 minus 1 over 2 b1. That's the solution for the B3. Yeah, which is why if you write down B equal to B1, B2, and this is minus half. Okay, that's the answer.
Is B1 and B2 automatically free to use?
Yeah, in this case, free to choose.
Oh, maksudnya. Okay.
Yeah, when we write like this, it means that B1, B2 free to choose.
Oh.
Okay.
Kalau nggak nulis di
Huh? You still have to write this. Okay. When you are doing the examination, you still have to write this. Because the question asks you, find out admissible B, right?
admissible.
Admissible means B that can make this to have a solution. I write down here already. You don't read it?
I read it, but I don't understand.
Nggak ngerti
I thought we just need to.
I make a bracket in here. Admissible B to the problem means B that makes the solution consistent, or B that makes the problem has solution.
Solution, no solution. Eh?
B that makes the system has solution. You cannot read this, the sentence?
Enggak. The wording was fine.
I think it's high pressure.
No, I'm asking you to find out admissible B here. Find out the B, this B, factor B. Okay? And you know that B consists of B1, B2, and B3, right? Okay? And then the hint guides you to find out what is B3. B3 is a function of B1 and B2, right? Yeah, the final answer is this. So, no, you haven't answered the question yet, in that case.
Belum full tapi.
Not fully answering. You get the climax here. This is the climax, okay? But then after that, you still have to finish it. Yeah, you don't answer the question.
Salah.
Yeah, not complete lah. If that's the case, it's not complete.
Masih dapat. Wah, cukup kecil.
Yeah, maybe I will give you half lah.
Ya, oke lah. Better lah. Yeah, it's still better.
But yeah, in here I can see that you don't read the question carefully in this case. I make a bracket in here. Yeah, find out admissible B to the problem. What do you mean by admissible? Do you know what this mean by admissible? You are admitted to SU. You can go into SU. You are allowed to enter SU. Is this sounds familiar to you? Admission. When you come to SU, you first coming into the admission process, right? What does it mean? Admission means it's a process so that you can go in, right? So admissible B here so that B can enter that problem. Okay, if B is not like this, B cannot be here. B cannot admit it to be to this problem. Or another. Okay, so now I'll write down the synonym then, so, like a composition or English class. Admissible B to the problem. I wrote in the quiz, I said that B such that AXB has solution, or B makes the B consistent. This is explained by the wording inside the bracket. Okay? You cannot understand that? You cannot. When you never use a bracket in your writing or essay? Never use bracket at all? Yeah? So why do you have problem when reading the problem?
Aku nggak tahu kenapa malah dikali bukan ditambah.
Because for me, because I I spent like 10 minutes on this. There's like still 4 minutes. Yes.
Okay. Any other question on this? Clear, yeah? The next problem is we have 3 columns. Your task is to show that C1 plus C2 plus C3 is true only for C1, C2, C3 equal to 0. Can?
I
Yeah.
explain it, sir. I explain.
Yeah, you just expand this. So this is, so I'll write down here that C1 plus C2 this is equal to C1, C2, and C3. So the only solution to this is just C1, C2, and C3 0.
Yeah.
And that's it.
Yeah, I explain if we use other type of C1, C2, it will become 3 times 1 matrix. It will not become 0.
Yeah. The only solution is C1, C2, C3 0.
Okay. That's
Okay. Less than 1 minute. You just write down. Yeah, your only job is just to expand this into this vector. Okay.
Then there is 3 equations. One column.
Say that again.
By say word of theory or like if
Well, what's the theory that you use there?
has 3
No, it's wrong. You are treating this as that problem. It has only one solution for it. In fact, if this is linearly independent, yeah, for whatever b that you have, the only solution is one, unique, not infinite. Okay, so you use the wrong theory on that. For number 3, yeah, for number 3, what's your idea for number 3?
for what if
For this matrix, are this column of A span R3?
yes, because it has 3 pivot point, which is the one on each column.
Because what?
The independent one.
Yeah, because these columns are linear independent, the 3 of them linear independent, so this one span R3. Okay. So there is no computation on that. You only need to explain that these 3 columns are linear independent, so they span R3.
Aku cuma bilang pivot sih tadi. Pak, kehapusnya linear independent.
Clear on this? If this come out on the exam too, you know how to answer ya.
So, kalau misalnya nggak linear independent salah.
It's wrong.
Pivotnya 3 salah.
Pivot is 3.
Pivotnya ada 3. Pivotnya ada.
How do you get that? It's from the slide, is it? Or from where? I never mentioned about pivot. although that's correct, yeah, because if you have a non-singular matrix, when you row reduce it, you will have 3 pivots like this. Yeah. In this case, we only have 2 pivots.
Oh itu, aku ngeliatnya dari itu. Kan kita kan ada tukar-tukar.
Yeah, I never mentioned about pivot, so you remember it for something else there.
Dia nyebutin di tutor.
Cuma
Tapi
mereka itu
gampang nginget itu, jadi aku
You use the pivot.
bilangnya 3 pivot.
sama sih.
Oh, I was expecting you to mention about linear independence. because when you are mentioning pivot, then you have to compute the pivot itself, right? Obviously, the pivot is there already. The pivot is there already. Okay, but that's the same, yeah. That's the same meaning.
Dia masih benar.
It is still correct, but I don't expect that actually. Yeah, it's like I want you to bring me good food. I want this food, but then you bring something else, but it is still good. I will eat it if it is halal. Okay. Yeah. Yeah, it's just you know.
Benar.
Oh iya benar.
Anyone else answering that this is linear independent? How many answer pivot?
Kalau dua-duanya.
Hah? Okay.
Tadi saya terus dan ini ya. Jadi hapus tulisan.
Okay, number four. If we add more columns to it, yeah, do these all columns remain linearly independent or not?
All column.
Huh?
There is still one.
Yeah, I'm asking all of them. Are these all linear independent or not? The answer is no. Okay. So when you are answering this, pivot cannot be used. Okay, which is why I really like you to avoid to use a pivot in answering that. Okay. When you are talking about span and then the basis, try to not use the pivot. Yeah, linear independence is more general. Okay, because when I say I add more columns to it, you cannot use the pivot terms. Yeah, the pivot is still 3. You cannot add more pivot, right? But then obviously this all is not linear independent, because when we have 3 rows of matrix or 3 rows vectors like this, the maximum linear independent columns are 3. Yeah, you cannot add more columns than it, like keep it linear independent. Okay. Are you still answering using pivot?
Yeah.
Salah ngerti soalnya.
No, I'm asking linearly independent and you answer pivot.
Karena kan kalau misalnya pivot harus linear. This way. Itu salah.
Can you read the question again, sir?
If we add more columns to this matrix, do these all columns remain linearly independent or not?
Gue jawabnya.
Gue jawabnya yang pertama.
Gue jawabnya ditambah si
Yeah.
Ditambah si
No, the original one is linear independent. When I add column, I'm asking all of them. I'm asking all of them. They are not linear independent. No. If you are asked only the 3 first column, then it is linearly independent. It is correct, but you are not answering the problem. You know what I mean? Yeah, you understand what happened, but you don't answer me. You see? That's different, right? Okay. Number 5. If A is a 3-row matrix, what is the required number of columns so that columns of A are linearly independent and they span the vector space R3? It's the same question to this, yeah, actually the same concept.
If it's only required for linear independent,
No, 3.
Itu lu harus jawab berarti pakai kedua-duanya kan?
what if A equals
And they span the columns the question asking for the number of columns, yeah. Okay, you have it is 3-row matrix, so 3 rows like this, yeah. So the question is that how many columns of A so that these columns remain linear independent and then they span R3.
Kalau misalnya cuma
If you answer 2 columns, sir, yeah, it can be linear independent too. If you answer 1, yeah, it is to itself, right? But it doesn't span R3. So the question asks you linear independent and span R3.
Kalau aku jawabnya linear independent satu kolom, kalau R3 karena R3 jadi 3 kolom gitu.
So what's your problem that you're answering that?
Ya, masih mendingan kalau misalnya aku jawab dua-duanya gitu satu kolom satu.
So what's the final answer? You only answer to span you need 3. If it is linear independent you need 1. You say or. I'm asking and. You cannot failure in reading the question. I'm asking and they span the vector space. And mean they have to both satisfy. Okay. Okay. Okay lah. Just accept the defeat then.
Dan nomor-nomor doang. Gak belajar katanya.
Ay, nomor 4 salah pak. Jawaban kedua salah.
You see, when we talk about basis in here, this is the definition of basis, yeah. It says and in there. Don't read as or. And or is completely different. Yeah. If it is and, it has to both satisfy both statements. Okay. So the question number 5 is saying about the basis. Question number 5, it asks you how many number of columns so that the columns of A are linear independent and they span R3. Then the question is similarly asking to you, if you want to make a basis for R3, how many columns that you need? Huh? Yeah, the answer is 3. If you want to make a basis for R4, how many columns you need? 4. Why we need 4? Because for a basis, they have to linear independent, then they span the R4. So they will be the basis for R4. Okay. The next thing on basis that I want to remember is that if, let's say, you have 2 sets of vectors, okay, and these are linearly independent. Let's say the first vectors, I have m columns of them. M is undefined here but finite, yeah. And the second set of vectors, v1 up to vn. Okay, n can be 10, 16, whatever number, I don't know, okay, undefined in here. But if we say that this set of vectors are both bases for one vector space, then this m and n must be the same. Okay, because let's say you want to make a basis for R3, you cannot have a set of 2 columns and another set of 3 columns. You cannot. Both must be 3 columns for R3, yeah. If you say that let me give an example, yeah. Let's say you have a collection like this, and then another collection of okay. this one have two vectors, yeah. This one have two vectors. Add three vectors over here, three, yeah. We cannot say that this is the basis for R3 and this is also the basis for R3. We cannot say that because they have different number of columns. Okay. If I ask you a question on this, yeah, this is a 3 rows, yeah, 3 rows column. This is linearly independent. Okay, does it span R3? Is it span R3? No, yeah, because not enough number of column. Does it span R2?
Yes. No. Actually,
subspace R2.
Span R3? No. Subspace of R3, correct. Yeah. So when the question is what kind of vector space that this one span, the answer is subspace of R3. We don't know if it is R2, ya.
Oh, maksudnya gitu.
Okay.
Jawab salah-salah sih.
Any other question?
Ini salah-salah. Oh, telat. Oh, salah.
Okay. We will have another quiz for chapter 8, yeah. So just prepare yourself. Chapter 8 is about eigenvalue. Eigenvalue. And the basic thing is coming from chapter 7.
So we skip.
Yeah, I want to tell you that for exam we will not include inverse.
Oh.
Yeah, inverse, determinant, there is no.
Yeah.
Kramer's rule is not included in the exam. Okay, which is why I just want to discuss about important concept in here, yeah, which will be used in the examination. Now, the dimension of the vector space. The dimension of vector space is determined by how many factors that forms the basis. Okay, if it is R2, then it has two bases, so the dimension of R2 is 2. Okay, and so on and so forth for R3, R4, and 5.
So,
Yeah.
the basis is seen from the independent column or row, right?
The basis of what?
Is seen by the independent column or row.
It can be one of them. It depends.
So from that one, can we say it has a basis of 3 for the row? Basis.
You can take basis from the row, of course. Yeah. But then when we are saying span in here, yeah, span means you multiply your columns with a constant. You take linear combination of your columns. Okay. But if you want to take basis for a row, then you have to take linear combination from the row. So that means it's like you are taking the transpose of your problem. So in that case, you have this problem. This is column-based basis. But for the row-based basis, then you will have this. Then this is the row base. Okay. Yeah.
Ya, gue juga bisa gitu tadi. Gak boleh ternyata. Ya, oke. good.
Okay, now about the orthogonal factors. Just now, some of you are discussing what is orthogonal factors. What is your answer just now?
Vectors that are perpendicular. Two vectors that are perpendicular.
Yeah, orthogonal factors are factors that are perpendicular to each other. If I say V1, V2 orthogonal, then it means that V1 is equal to the dot product is 0. An example of this is what's the example? If it is an xy plane, what's the easiest example of orthogonal factors?
1, 0, 0, 1.
Yes, correct. It's that, yeah. Here this is 1, 0 and this is 0, 1, yeah. These are orthogonal. So when they are orthogonal, they are also linearly independent. Okay? So orthogonal means that it is linearly independent. However, if it is linearly independent, do they orthogonal? Not necessarily, yeah. For example, is this vector? These are orthogonal. Sorry, these are linear independent, yeah. But when you take dot product, this is not 0. So when I say I have a set of 3 orthogonal factors, if I say this, I have a set of 3 orthogonal factors, do they span R3? What's the answer?
A set of 3 orthogonal.
Yeah. Not probably.
Yes.
Definitely yes. Definitely.
Necessarily.
Span out. Kemudian juga ke orthogonal. Dia 3.
Is this clear? Yeah.
Yes.
For you to span a vector space, yeah, the only requirement is that it has to be linear independent. Yeah.
Yang independent.
Yeah. If you have 4 orthogonal factors, then it can span R4. What if I say a set of orthogonal factors with 5 rows? The row is 5, but I have only 3. 3 factors, but then it has 5 rows. Does it span R5? These are all orthogonal, yeah?
A set of gimana sih?
No.
3 with 5 row. Wait.
5 rows. Does it span R5?
No.
You said no, you say probably no? Or definitely no? Still thinking Alfred?
Udah bias deh.
Biar beda.
No.
Sean, Nabil, what's your answer? No. Brian? Huh?
No.
You say no? Okay. Those who said no will get plus point for the quiz, yeah? You said no.
Hey, let's go! Nah, main regret.
Okay.
Bener answer.
It's not.
Karena kolomnya kan cuma. Yeay.
Yeah, it only span 3, yeah. So only a subspace in R5. But not necessarily R3, yeah. Not necessarily R3, but a subspace in R5.
You know that 5 rows, 3 orthogonal vectors. So the reason why it's not R5
because you don't have enough column.
Nyesal sekarang. Kalau ada mic.
Itu benar dapat plus point, sir.
No, so that you are serious in answering.
Okay.
Yeah. But I will give the bonus point. Yeah. Yeah, I will give them.
Yes, sir.
Okay. Okay, seriously in answering lah. Don't be like that. Okay.
Expect that.
I will answer seriously from now on.
I see the flow in my way.
Okay, the next one. So we know that orthogonal linear independent. So if I have 5 then, if I have 5 orthogonal vectors with 5 rows, I will change the question. Is it a basis for R5?
Yes.
Yes.
Yeah. So is it a basis?
Yes.
Yes. Yeah, it is a basis. Okay.
Sebenarnya linear independent.
So when we say this, don't reconnect yourself to the pivot again. No. Don't connect it to the pivot. Connect it to here, yeah.
Yes, sir. Yes, sir.
Okay.
We'll not do that.
Pivot is only when you discuss the row reduction,
Oh.
get upper triangular. That's okay lah. Although they are interchangeable terms, but it's too specific. Okay. Not so general that you can bring it to all of the concept. Okay. No. You will still use pivot when you are doing Gaussian elimination. You need pivot. Okay. It is correct that the number of pivot is the same as the number of linearly independent columns. Okay. Now let us discuss about orthonormal vectors.
Itu paralel.
Apa? Orthonormal? Enggak. Unit
Yeah.
vector.
What is orthonormal?
Orthogonal tapi unit vector.
Yeah, orthogonal unit vector. So what is it about unit vector?
Like this one.
Length is 1. Okay.
Wow.
Nggak bonus point, sir.
No.
Neutral. Tadi kan minus.
Tadi dikurangi.
Tapi kan tadi orthogonal aku yang ngomong gitu.
Kan nggak ada
So
outlier.
does this
This is why we cannot get point. Tahu ada.
is this orthogonal?
Yes.
Is this orthonormal? Orthonormal?
Yes.
Yes. Yeah. So orthonormal here
Tadi bilang enggak, gue berapa?
is orthonormal means that it is orthogonal and the norm of the vector is equal to 1.
Oh.
Yeah. So for orthonormal set of vectors, they have to satisfy these two requirements. Okay. The first one is orthogonal, and then the length is 1. Length is 1. Yeah. This is the example. The length of this vector is 1. Length of this is also 1, and they are orthogonal. So this is orthonormal vectors.
So
Yeah, identity matrix have orthonormal vectors. Okay. Say that again. Straight line? No. Orthonormal means a set of vectors. Yeah. Okay. Let us define.
Gitu dong.
Yang tadi ortogonal coba panjang satu.
yang satu lihat dari mana?
Itu satu.
Kalau dua berarti enggak.
Enggak
Dua nol.
Itu ortogonal.
Dua.
Kalau 2 itu artinya ortogonal tapi enggak ortonormal. Kayaknya.
If they are orthogonal, and
Kalau double
eh, equal to 1. Okay, so orthonormal must be a collection of vectors. You cannot say that 1, 0 is orthonormal. No, you cannot. It's a collection of vectors. Huh? You don't sum it up. No.
I mean like
Why summing it up? Huh?
all the vectors that are available.
You don't sum it up.
Yeah, I don't mean sum it up, but I mean all the vectors that are available. Sir,
It's a set of vectors.
Yes,
Yes.
so if it's 0 to if it's 2 0 0 2,
Yeah,
is it? It's not orthonormal.
it's not orthonormal.
So
Yeah.
it can only be like one. Okay.
Magnitude must be 1.
Oh, okay. Okay. Okay, understand.
Length or magnitude, ya magnitude lah. Or the norm of that vector is 1. Ya, length, magnitude, norm.
Okay.
Okay ya. Don't sum it up.
Okay, wrong wording
In,
aja.
in exam, you say orthonormal, I sum it up everything. Oh,
Kayak gini nih. Normal.
yeah, a good question from Dylan just now. If we have 2 0 and then 0 5, yeah, this is orthogonal, but they are not orthonormal. Okay, if I have a set of vectors, let's say I have P1, P2 up to Pn, let's say, yeah, n of them. If these are orthonormal, if this is orthonormal, yeah, orthonormal, all of them, then it means are this span Rn? Is it span Rn?
Yes.
Yes.
Wait.
Orthonormal. Span Rn.
Kalau
I have to say, and these are all in Rn, okay? So it is n by 1 vectors.
Oh,
N by 1, okay?
Oh, kalau is
Ah?
by one, yeah.
Row is n.
Zero is it.
Row is n, okay? And I have n of them. Okay? In Rn and then the let me give a number lah. Let's say I have P5 only, and then they are in R5. Okay, so only five vectors. They are orthonormal and they have 5 rows. Yeah, R5 means 5 by 1. 5 row, 1 column. Do they span R5? Huh? Yes? No? No?
no.
Alfred? Did these vectors span R5? 5 vectors that is orthonormal.
the set of vectors spans are
Half point.
Nggak gitu.
Yang penting kan confidence. Five row, one column. Confidence.
Michael,
For it to be one, you have like the column that goes
why 1? Yeah, orthonormal.
Do you mean all of them combined will have 5 row, 1 column, or each of them have 5 row and 1 column?
No. Oh, so you misunderstood that, yeah. So what I mean is that each of them is in R5. Each of them.
Oh, iya.
Each of them, ya.
Just 5 row and 1 column.
Gitu.
Oh, okay. So yes.
Oh yes. Okay.
Yes. I misunderstood it.
Okay. Michael? Yes, also.
Dijam dulu ya.
Yeah, not sure, ya. So the answer is yes.
Yes.
Is it basis for R5?
Yes. Yeah. Yes.
This is orthonormal, ya, not orthogonal, you know.
Yes.
Yeah.
Ya, berarti dengan
So they are linearly independent.
Yes.
Or
Yeah.
they also
Span basis.
Yes.
It is a basis, yes. Okay.
Plus 15.
Okay. So we are done on it, yeah. And then for orthonormal factors, the good thing on that is that when you multiply with itself, take the dot product of itself, then the result is what? This is the orthonormal factor from that. We take the dot product with itself. What's the result?
Product. Volume.
kan
Iya.
gini.
Yes.
With itself.
With itself.
Oh, nih.
Oh, it will become
This is zero, right?
it
Ah,
will
so with itself,
it's
huh? Zero. What do you say? Zero.
transpose. No, itself.
Enggak dong,
Itself. Itself.
What's the answer?
Answer itself.
We take dot product with itself.
It transpose dulu kan tuh. Transpose.
Iya, transpose. Dot product is you take transpose.
Aduh, apa ya?
Zero. Brian? Hah? Vector time vector.
P1.
Why become identity?
I answer P1.
Hah?
P1.
P1. Alfred?
Aku ganti
no
P1 juga
idea.
deh. Sir.
Kenapa?
Michelle?
Aku ganti P1
Go on.
juga. Sir.
Go on. Okay, let me give you a chance again, yeah.
Boleh, Pak.
I said the factors are said to be orthonormal. These are orthonormal, yeah. Those are P1 is orthonormal, yeah. If they are orthogonal and their length is 1, magnitude is 1, or the norm is 1. Okay. So if I take dot product of that factor with itself, what do we get?
1.
1. That's correct.
Nanti 1 guys, 1.
The answer is 1.
0 1 1 0 kali-kali 1.
0, 1?
1 0.
Kan, kamu misalnya itu 1, 0. Terus satunya jadi 1, 0. Mau kali kolom kan?
1.
Okay. How do you compute the length of a vector?
Magnitude-nya kalau transpose kali itu dapat magnitude.
Which is why you cannot expand. Okay. If we have a vector of v, let's say v, yeah, this is in R10. R10, okay. So I can write down v is equal to v1, v2 up to v10. What is the length of v?
Kali V transpose-nya. V transpose kali V itu.
So based on what Radit said, then we have to do the square root of v1 square plus v2 square v10 square, and then we take the square root.
Gue salah kali tadi. Boleh.
Itu jadi kali ini kan apa? V transpose.
Okay, and this is true, correct, but that's too long to write. What about this is 100? So what you write down is just that, yeah. V transpose times V, and you take the square root of it.
Which is 1.
Yeah, and which is 1. If it is orthonormal, it is 1, yeah. Orthonormal, the result is 1. No, orthogonal we don't know. But orthonormal guaranteed to be 1.
Unit magnitude itu 1.
Always 1. If cannot 1, if it is not 1, it is not orthogonal, of course.
Orthonormal.
Not orthonormal, yeah, sorry. So if we take out the square root, what does it become?
Square.
Yeah, that is without square root, right?
1. Right.
This is the square root, right? Square root of this is 1. So what is inside here?
The orthonormal.
Yeah, the square root of V transpose V is 1. So what is V transpose V?
1.
1 also, right? Yeah. You square it become 1. Yeah. So answer is 1.
Cuma make sure. Just to make sure you are.
Okay. So I believe these are all the important thing that we have to discuss for chapter 7. The next thing on here is that you need to find out the solution space for both particular and the homogeneous solution. Yeah, I will just discuss about this one, null space. Null space is the space where this solution, this problem is satisfied. Yeah. Null space is that all x that satisfy this equation. That's called the null space. Okay, let me give you an example. If we have this equation, x equal to 0, and then your a is what will be the solution space for this problem? If a is this, then how to get the solution?
All row 3 is dependent on.
Yeah, row 2 dependent on row 1, row 3 also dependent on row 1. Okay.
Oh, okay.
So how do we get the solution space? You augment the matrix first. And then you try to eliminate the second row and the third row. Okay. What do we do here? R2 minus
2R1.
2R1. R3 minus 3R1. 3R1, yeah. So what's the pivot that we use? The pivot that we use is this one, yeah. Only one pivot. Only one pivot, so only one.
Only one what?
One pivot, so
One
the rank is 1.
Rank
Oh.
1.
The rank is 1.
Nungguin jauh.
I'm waiting. So what's the result here?
0.
Oh, all 0, yeah.
0. Oh yeah.
So what do we do?
Define it by
What do we do?
x1. Define it by r1.
Just off.
It says here 0 times x3 is 0. 0 times x2 plus 0 times x3 is 0. So how do we get x2 and x3?
We
Sir,
itu harusnya
R3 minus 3R1.
yang
Just
bawah
six,
enggak?
Enggak.
Oh iya.
Bawah kan 6 harusnya.
Sorry.
Gak bisa di ranknya 1 ya. 2.
3.
Harus pakai
368, 369, sorry. 369, yeah, sorry. I made a mistake.
Jago kali.
Nanti
This is 369. Okay, now it's 0, yeah.
0.
So how do we get the answer x2 and x3?
Free to choose.
That's correct, yeah. Because we have 2 rows that is 0, that means x2 and x3 free to choose. You free to choose them. So finally, when you are expressing the answer, you will say that let me say no. if I choose x2 to be 1 and I have x3 to be 0, what will be x1?
Wait.
Yeah, x1 plus 2x2 equal to 0, yeah? So x1 is minus 2x2. Yeah, this is the first equation. For my second choice, because I really to choose x2 and x3, right? Free to choose. So in here I choose x2 0. Then I will have what is my x1?
Zero.
What is my x1?
Zero to x.
How come, sir?
X3 is 0.
X3 is 0, right?
Sorry.
How come it?
x3 is 1.
Okay.
This is 1.
Okay, now makes sense.
And so I have two solutions because rank is only 1, yeah. So the solution that can make this to be 0, we have 2. Yeah, we have 2. And in here we have minus 2x2. This is 1, 0. And also another thing is this is x2. This is 0 and then this is x3. Yeah. And this one I can write down as and also x3. Okay. So this is my solution space. Yeah. X homogeneous is this. This two.
That is the final answer.
And you know, this factor and that factor, are they linearly independent?
Yes.
Yes, yeah, because of this, yeah, 1, 1, 1 and 0, 0 here, yeah. This is linearly independent. Okay. So what I can say in here is that minus 2, 1 and 0 and also minus 3, 0, 1, these are inside the null space of A.
Why is it X homogeneous?
Huh? X homogeneous is that X that satisfies this equation. That is called X homogeneous.
Sorry,
Okay.
if we can choose x2 and 3 to any number, can it be the same? Like, can I choose both of them to be 0, or shouldn't I do that?
What you have to choose is that these two choices must be linearly independent. Okay. So when you choose, well, you are free to choose x2 and x3 for the two solutions, right? We need to have two solutions. So this choice must be linearly independent. If they are dependent, then it is just you only find one solution. Okay. So in this null space, how many factors that forms the basis for this null space? How many factors that compose the basis for the null space? How many? 2 factors. Okay. So which is why the dimension of the null space of this matrix is 2. Okay. And rank of A, just now we mentioned what? 1, yeah.
1.
So the rank of that matrix plus the dimension of the null space must be equal to the size of the matrix itself. Okay. So for this case,
The rank plus nullity.
rank is 1 and the nullity is 2.
Can you explain like what exactly null space is?
Null space is a vector space where when you take a vector from that space, this will hold. this equation will hold. Okay. You put here like this, alpha times that, it is the null space of A. I have to get plus, yeah, it's plus.
So if we plug the A times that, it should be 0.
Yes. For whatever alpha and beta that you choose. Okay. The result is 0. Yeah, real number. And that's about the nullity, yeah. So we discussed null space, nullity. Although this will not be included in the exam, yeah. But this is interesting to follow. So when you are finding the answer to AX equal to B, you need to find out both homogeneous and the particular solution. Both of them must be computed. Okay. Let's say, for example, that matrix, yeah, you have AX is equal to, let's say, 5 minus 3 and 2. Let's say like this. Suppose you find out X particular is A1, A2, A3. Let's say, yeah. Then your final X must be your XP plus X homogeneous, which is A1, A2, A3 plus alpha times minus 2, 1, 0 plus beta minus 3, 0, 1. So that's the complete answer.
And it's when the same as yesterday when we find that X is freaking we must do the AX.
Yes. Yeah.
To get the solution.
Samanya awalnya ada answer.
So let me say this again. If you find this problem and then you are asked to find the X, and then you know rank of A is less than 3, then you have to find out the solution to 0 first. Find out the homogeneous solution first. After that, find out the solution to this, yeah, and then plug in all of them.
So even if X has no solution, we still have to do the AX.
Even F, what?
X has no solution.
If it is no solution, then no need to say.
Only the
Infinite
one.
solution.
Yeah, only infinite.
Infinite
That we
solution.
need to do it.
No.
In infinite solution?
Yeah, 0x equals 0.
Say that again. I don't understand. What's the
So,
problem?
If we do Gaussian and then the last row is 0, then we need to use this.
Yes.
If it's 0x equals constant, no solution, then we just say it's
Yes. No solution.
The alpha and beta part, it's depend on how much you got the freedom, right? Like when we do like 2x.
Alpha and beta you choose freely.
I mean, like if we only found that the last row we can freely undo that. That means it's only alpha.
Yeah,
right?
correct.
No
Only
beta
alpha,
part.
no beta. Yeah.
Oh.
So which is why the dimension of this homogeneous solution depends on the rank of A itself. Yeah. So because rank of A is 1, we only have one factor in here. The nullity represented by these two factors. Okay. So let us end chapter 7 here. For the remaining concept, you can read it on your own. Determinant, this is easy to follow. I don't think it is difficult to follow. Until the inner product space, you can read on your own. Okay. Then next Tuesday we will continue with chapter 8. I'll see you again on Tuesday.